Hello everyone, I am Ishati Rabban, a PhD student at University of Maryland. Today I am going to present my work on the resilient coverage maximization problem, or the RCM problem. This work was done under the supervision of Dr. Pratap Tokekar. First we define the RCM problem. In the RCM problem, we are given a set of robots and a set of targets that the robots want to cover. For each robot, there is a set of trajectories, one of which the robot will follow. Each trajectory covers a subset of the targets. We are also given the attack size alpha, which represents the maximum number of robots that may fail. The objective of the RCM problem is to select one trajectory for each robot such that in case of a worst-case failure of at most alpha robots, maximum coverage of the targets is achieved. The RCM problem was introduced by Lifeng Zhou et al. They proposed a two-phase greedy strategy to solve the problem. We call Lifeng's algorithm the two-phase greedy algorithm, or the 2PG algorithm. We identified two limitations of the 2PG algorithm. The accuracy of the 2PG algorithm is approximately 90%. By accuracy of an algorithm, we mean the ratio of the coverages of the algorithm and an optimal algorithm. Also, the running time of the 2PG algorithm is quadratic on the number of odd trajectories, which we denote by P. In our work, we propose two algorithms that performs better than the 2PG algorithm in terms of accuracy and running time. The first algorithm we propose is called the ordered greedy algorithm. In this algorithm, first we sort the robots according to some sorting criteria. Then we consider the robots in the sorted order. For each robot, we greedily select the trajectory that maximizes the incremental coverage. The running time of the ordered greedy algorithm is order P. We use different sorting criteria that gives us different variants of the ordered greedy algorithm. For each sorting criteria, we consider both increasing and decreasing sorting order. Experimental results show that the variance with increasing sorting order gives better accuracy than the 2PG algorithm, and also the variance with decreasing sorting order. The second algorithm is based on the idea of local search. In this algorithm, we start with an initial solution. At each iteration, we consider all neighbors of the current solution. By neighbor of a solution S, we mean another solution that differs from S by exactly one trajectory. Then we calculate the estimated coverage of all neighbor solutions and select the neighbor with highest estimated coverage. The reason we calculate an estimation of the coverage is that calculating the actual coverage of a solution is an NP-hard problem. The local search algorithm terminates when there is no neighbor of the current solution with higher estimated coverage. The running time of the local search algorithm is order I alpha PR, where R is the number of robots and I is the number of iterations of the local search algorithm. We use two different initial solution and two different coverage estimation methods, which gives us four variants of the local search algorithm. Experimental results show that the accuracy of the local search variants is comparable or better than the 2PG algorithm. We conduct an extensive set of experiments to demonstrate the effectiveness of our proposed algorithms. Our experiments are simulation-based. We used synthetic 2D data set, which we generate as follows. The location of the robots and targets are chosen uniformly at random within a 2D space. We consider four trajectories for each robot, and each trajectory covers a rectangular region as shown in the figure. The targets falling inside the rectangular region of a trajectory are assigned to that trajectory. We select the top performing variant of the ordered greedy algorithm and the local search algorithm and compare their accuracy and running time with the 2PG algorithm. Experiments show that both of our proposed algorithms have higher accuracy than the 2PG algorithm, and the accuracy of the local search algorithm is slightly better than the ordered greedy algorithm. In terms of execution time, the ordered greedy algorithm outperforms the local search algorithm and the 2PG algorithm. And when the number of robots and targets are greater than 1,000, the local search algorithm takes less time than the 2PG algorithm, and vice versa. So that concludes my presentation. If you have any question, please feel free to ask.